Hello students, today we'll discuss about engineering alloy steels and its designation, that is our unit number 5. So what are the contents of alloy steels and designation? First we'll discuss about the classification of steels and few terms related to stainless steel, sensitization, weld decay of stainless steel. Next part we'll discuss about tool steel, heat treatment of high speed steels, which is the very important topic related or exam point of view. And next again important point is heat affected zone, which we have a practical on same topic too. And next one, the classification, that is IS standard, AISI, SAE standards, that is designation of steels. So before moving to that, what is iron carbon diagram and what are the parts related to that is to be understood. That is, in previous lectures we have discussed about phases, equilibrium diagrams and critical temperatures. Similarly, we have discussed about transformation products of equilibrium diagrams and cooling of eutectoid and hypoeutectoid steels. Coming to iron carbon diagram, what were the important points, that is steels, cast iron, phases, important critical temperatures already we have discussed. Again, that is the alpha phase, austenite phase and uh, delta phase. That is, if we will consider the point, so first phase is alpha phase, that is shown over here. Next phase and next part is eutectoid point, eutectic point, monotectic and peritectic. Out of this all, eutectoid point is of much importance to us because classification of steels will depend on the eutectoid point and the percentages. So how steels are classified, that is plain carbon steels and cast irons, that is up to 2% of carbon addition in iron are called as steels, whereas greater than 2% we have cast irons, as we know. Then steels up to 0.8% of carbon are hypoeutectoid steels, whereas greater than 0.8% carbon we have hypereutectoid steels. So first phase which we were discussing is alpha ferrite, that is in olden days it was named as ferrum. It has BCC structure and its solubility up to 727 degrees Celsius. Properties: soft, ductile, hard. The microstructure will look like this, that is purely ferrite with the green boundaries. Next part is austenite, which was given in the name of Sir Austin, who discovered beta ferrite as austenite, which is appearing at 1147 degrees Celsius. That is 2% of carbon solubility is at 1147 degrees Celsius, which is stable only above 727 degrees Celsius. And similarly, it is also soft, ductile, and malleable phase. This is the microstructure of austenite, that is the green boundaries and pure austenite phase. Next one is delta ferrite. It is similar to alpha ferrite, only difference is that it is appearing at higher temperature, that is most probably around 1452 to 1400 degrees Celsius. Next one is the microstructure of cementite, that is compound, is orthorhombic, that is not equal in all directions. Similarly, how is the microstructure, it look like this, which is the most brittle phase in the iron carbon system. This is the summary of all the phases available over here. So that's all for today's lecture. In next lecture we'll continue with alloy steels.